Solving polynomial inequalities algebraically. I am not really a big fan of this method since we have the graphing calculators and we know so much about sketching graphs of polynomials. I think this is a little bit more tedious, but I'll show you an example, and you can also look in your book, in the Bittinger book, for more examples. We're going to start out pretty much the same way as solving graphically. We're going to get the polynomial to one side and 0 on the other. We're going to have to find our zeros, but now we're going to use a number line and we're going to divide it into intervals based on those zeros. We have to choose a test point in each of the intervals and then determine the sign of that polynomial at the test point. Okay, sometimes it's easier just to see the example. Okay, so we've got x squared minus 6 greater than 5x. Put that all on one side together. X squared minus 5x minus 6 greater than 0. Okay, so we want things that are going to be positive. Well, if I need to find the zeros to break up my number line, I would factor this as x minus 6 and x plus 1, which tells me x is 6 or a negative 1. So I've got my number line, and at the negative 1 I marked a 0, and at the 6 I mark a 0. So I have kind of three sections here then on my number line, right? And I choose a test point in each of those. So maybe the negative 2, something between negative 1 and 6 would be 0, something easy. And then something in that last interval, let's try 7. So what you have to do is these are the x's and you're going to plug them in. So negative 2, if I plug that in up here, let's see, negative 2, that make that negative, that would be negative 2, that would be negative, and negative times negative is going to be a positive result. I don't really care what the number is, I just care what the sign is. What about if we plugged in a 0? Well, this would be negative and this would be positive. Negative times positive would give me a negative in the middle. So all of these numbers between negative 1 and 6 that you would plug in would give you a negative result. What if we plugged in a 7? Well, 7 minus 6 would be positive. That would certainly be positive, so the result product would be positive as well. And we're looking for, again, numbers that are going to give us a positive answer. That'd be this first section from the negative infinity up to our negative 1, not including because it's not or equals to. And then again from our 6 to positive infinity. Okay, this last one, just to show you again how much more cumbersome I think this method is. If I'm going to solve this one, I'd have to put it all on one side. So 2x cubed plus x squared minus the 11x minus 10 less than or equal to 0. It doesn't factor, so I have to use my rational zeros theorem and come up with some possible rational zeros. I did go ahead and sketch the graph, and then I can tell that negative 2 and negative 1 were on my list, and they're also zeros. Now this is between the 2 and the 3, and the thing in my list that fits that would be 5/2, and it does turn out that that's the 0. Okay, so on my number line, I mark at negative 2 a 0, I mark at 1 a 0, and I mark at 5/2 a 0. Then you'd have to choose test points in each of these, so maybe a negative 3. Then something between negative 2 and negative 1, negative 3/2. Okay? And then between the negative 1 and the 5/2, you could use 0, and something from 5/2 to infinity, you could use 3. And then you'd have to plug each of those in and see if you get positive or negative results. I think that's a lot of work. When I've already got the picture sketched here and I'm looking for less than or equal to 0, I want the below. So I want this section back here from negative infinity, right? From negative infinity to negative 2, and then from negative 1 to 5/2. The picture, I think, is going to be a lot easier.